Section 2.5, 2.6, Example 7. How many people are in the room if there are 78 handshakes and each person shook every other person's hand once? In this example, we are looking for n, the number of people in the room. N, choose 2. We are picking 2 people at a time, and there are 78 handshakes. Using the formula NCR equals n factorial over n minus r factorial times r factorial, in this example, we have n factorial divided by n minus 2 factorial times 2 factorial equals 78. To begin to solve, we are going to multiply both sides by 2. Because 2 factorial, 2 times 1 is 2. To get rid of that, we are going to multiply both sides by 2 to get n factorial over n minus 2 factorial equals 156. We can rewrite n factorial as n multiplied by 1 less n minus 1 multiplied by 1 less n minus 2. And we notice that n minus 2 is on the bottom, so I'm going to stop there and say n minus 2 factorial, so that the n minus 2 factorial on top and bottom can cancel out. We are then left with n times n minus 1 equals 156. Distributing, n multiplied by n is n factorial. N multiplied by negative 1 minus n equals 156. This is a quadratic equation, so we want equals 0. We are going to subtract 156 from both sides. And we end up with n squared minus n minus 156 equals 0. To finish solving, we need to factor or solve this quadratic equation where we have a sum of negative 1 and a product of negative 156. What plus what will give me negative 1, and the same two numbers multiplied together will give me negative 156. 12 times 13 will give us 156. We did a negative, so one of those numbers need to be negative. Adding those two numbers together, we can see we need a negative 13 to get a sum of negative 1. So 12 and a negative 13 works. So that trinomial factors into two binomials, n plus 12 and n minus 13. Using our zero product property, we have n plus 12 must be 0, or n minus 13 is 0. Solving for n in each case, we have n equals negative 12, or n equals 13. N has to be a positive number, so we reject the negative. And there's one solution. N must be 13.